Okay, these are going to be the notes on section 3.3, which deals with the unit circle. As we know of our unit circle, we're going to start off here talking about the angle measures. So looking at our unit circle here on our coordinate plane, with the center being the origin, we have angles that we've already talked about a little bit, starting with 0 degrees and going clockwise with our special triangles being inset. We have, with the hypotenuse of the triangle being 1, we will have angles created at 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then we keep on going, another 30 to 120 degrees, 150 degrees, 135 degrees. I screwed that up. Keep forgetting the 45s. 135 degrees, 150 degrees, 180 degrees, 210 degrees, 45 is 225 degrees, then the 60, 240 degrees, then we have 270 degrees, 300 degrees, 315 degrees, and 330 degrees. When we look at those as radians, zero degrees is still 0 radians. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 120 degrees is 2 pi over 3. 135 degrees is 3 pi over 4. 150 is 5 pi over 6. 180 is pi. Then we keep on going. 210 is 7 pi over 6. We get 5 pi over 4. 4 pi over 3. 270 degrees is 3 pi over 2. Then for the last one, 300 is 5 pi over 3. 7 pi over 4. 11 pi over 6. And it comes back around to 2 pi. So we have 0 or 2 pi, depending on as we go around the circle. So, with a unit circle, we're going out 1 unit. So the value at this first point is 1, comma, 0. I'm using 2 different colors here. That's because each of these are a different trig function. For 0 degrees, we have the cosine being the x coordinate, and we end up with the sine being the y coordinate. So when we look at it as a unit circle, we have the cosine value followed by the sine value. And at 0 degrees, or 0 radians, we have a cosine of 1 and a sine of 0. As we go around the unit circle, for a 30-degree angle with a hypotenuse of 1, the value for cosine is root 3 over 2, one of those special triangle values. For the 45, the special value was root 2 over 2. For pi over 3, it's actually 1/2. And at 2 pi, it becomes 0. For the sine values, they go the opposite. So they go from 0 to 1/2. It's going to be the same value as the cosine for 45, root 2 over 2, because the sides are the same. For the 60, it's the root 3 over 2 now, as we work our way up to 1. Now these values get transposed into the other 3 quadrants because it's symmetrical. The only difference sometimes is the sign. In the second quadrant, cosine is negative because that's going to be the x value. Negative 1/2. Coming back down the circle, negative root 2 over 2. Negative root 3 over 2. And a negative 1. Working our way back down to 0. Negative root 3 over 2. Negative root 2 over 2. Negative 1/2. Back to 0. And then we go around the other way. 1 positive, because we're on the x side, positive x side. Positive root 2 over 2. Positive root 3 over 2, back up to 1. For the sine values, they stay positive in the top 2 quadrants. So root 3 over 2 as we move down the y, root 2 over 2, 1/2, and 0. And they're negative in the third and fourth quadrants. Negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1, negative root 3 over 2, negative root 2 over 2, negative 1/2, and back to 0. That is the unit circle. Now we're going to talk about the application of the unit circle, or the start. We're going to use the unit circle from now until the end of this class. So now till January, you're going to be using the unit circle. So don't lose this. Keep this handy. If you made mistakes, print out a new copy, clean it up, use whiteout tape like I had to, but make sure it looks really good. We'll probably be adding more things to it as the term goes on. So now next I want to talk about the unit circle and circular functions. To do that, I'm going to switch views quick, so I'm going to have to walk over here. And I'm going to switch so that you can see what we just made, the unit circle, and you can see the notes we're taking, so that I can go up and point to both parts while we're taking these notes. So these notes are on section 3-3, unit circle, and circular functions. So we have our unit circle, and we've already discussed that when we have a piece of a triangle within the unit circle, I'm just going to put a little sketch here. And go 1 unit out. I'm going to draw in my unit circle. and I'm going to impose a triangle. The hypotenuse of the triangle is a 1. The side opposite is y, and the side adjacent is x. So looking at the angle, I'm just going to shade it or right there. To look at that angle theta, sine of theta is opposite over hypotenuse, y over 1, so it is y. Cosine of theta, adjacent over hypotenuse, is x over 1, or x. This is where we get the values from the unit circle we just talked about. For tangent of theta, opposite over adjacent is still y over x. And for our inverse functions, the cosecant of theta is 1 over y. The secant of theta is 1 over x. And the cotangent of theta is x over y. So for some of the problems we're going to have, they're going to ask us to find the exact value. We're asked for the exact value of sine 3 pi over 2. We are going to just go and look at 3 pi over 2. And they asked us for the sine, which is the y value. So we're going to get -1. Cosine 5 pi over 6. 5 pi over 6. Cosine is the x value. That is a negative √3 over 2. For the tangent, 5 pi over 3, we're going to need to divide the y value by the x value. Well, that's the same as taking the y value for tangent of 5 pi over 3, which is negative √3 over 2. And multiplying it by 1 over the x value, or flipping the x value, because we want the denominator. So the x value at 5 pi over 3 was 1/2. Flipping that means 2 over 1. Multiply, the 2's cancel, and we're left with a negative √3 for the tangent value. If it's an inverse function, so the cosecant of 5 pi over 4, the first thing we're going to do is we can find the sine and just flip it, which the cosecant is 1 over y, so the y for 5 pi over 4, 5 pi over 4, the y is negative √2 over 2, so flipping that, we get negative 2 over √2, and we got to rationalize the denominator. Times top and bottom by √2 over √2, and we're going to get negative 2 √2 over 2. The 2's will cancel, it's just negative √2. to find the calculator approximations, for each circular function value. Yeah. For number 1, if I do cosine 1.85, I'm going to type that in the calculator. Cosine 1.85, enter. Biggest thing is, if we're asking for these in radians, you got to make sure your calculator is in radians. So do these problems to double check your calculator is truly in radians. If it's in degrees, you got something like 0.9994, which is not correct. In radians, you will get a negative 0.27559, blah, 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 blah. To find the cotangent of 1.3209, you're going to take the tangent value of tan 1.3209, get that answer, and then do 1 divided by the answer. Or you may have a key that is x to the negative 1 power, or 1 over x. You can hit that button and it'll flip your fraction for you. But when you do that, you should get an answer of 0.255231. If you're not getting that value, then you need to check your process. Remember, the process would be to first take the tangent function, because most calculators do not have a cotangent function on them. A few do. The n-spires, if we were in class, this would be easy because the n-spires have a cotangent function. But most do not. So if we take the tangent of 1.3209, we get 3.91, and then we're going to take and go 1 divided by that answer, 3.91801, and that's what's going to give us the 0.25523, and I'm getting a little bit of a rounding answer at the end because I used a rounded value. Okay? So that's how you find the calculator decimal approximations. You will only use a decimal approximation when it is asked for. Otherwise, you are expected to find the actual value using the unit circle and getting exact values. Okay, last one. Find the value of theta in the interval 0 to pi over 2, so that means the first quadrant. 0 to pi over 2. That makes the statement true. So for the first one, tan theta equals 0.2126. To find theta, we're just going to take that tan to the negative 1 function on the calculator and type in 0.2126 and get our value. In this case, theta equals 0.209481, etc., etc. Okay? That's section 3 on the unit circle and circular functions. Look forward to seeing you in class.